Hey guys, today we're going to take a look at next lesson, 9.3.0. Now, the point zero is going to tell you that this is kind of an introduction to something we're getting ready to do, okay? And today's lesson is going to seem completely unrelated to what we've been doing as of late. So today is going to be a review of complex numbers. So when you were in Algebra 2, you used complex numbers. So for starters, let's just take a look and try to remind you of what complex numbers are. So when you're in Algebra 2, if you're dealing, maybe Algebra 1, you were probably introduced to this, but if you have an equation like x squared equals -1, there is no real solution to that. There's no number that you could square and get -1 as an answer. So what they do is they introduce this unit called an imaginary unit, which we use the letter I, and we say that I is equal to the square root of -1, which would mean that I squared, so if you square this, you get -1 as an answer. So I is the square root of -1, and I squared is equal to -1. And what that does is it allows you to evaluate negative square roots. So you think of something at like the square root of -16 as the square root of 16 times the square root of -1. The square root of 16 is 4, and then the square root of -1 is our imaginary unit I, and you get answers like that, 4i. Example B, the square root of -8. So again, we know that the square root of 8 simplifies as 2 radical 2, and then that negative that's in there is going to be our unit I. Now usually when we write something like this, we write it like 2I and then radical 2. We put the I in front of the radical so it doesn't, in case you draw your radical too long, it doesn't look like the I is under the radical, but that's how you would simplify the square root of -8. The square root of -27. So again, 27 is 9 times 3. 9 is a perfect square, so it would be 3i radical 3, and that's how you would simplify that. Okay? Now, these answers, all these answers up here, are examples of what are called pure imaginary. This is just an imaginary number, 4i. What we're going to talk about are what are called complex numbers. Now, a complex number has two parts. It has a real part, that's the number that's out front, and then it also has an imaginary part. So when you look at the bottom here, you'll see something like 3 plus 5i. This is a complex number. 3 is the real part, 5 is the imaginary part. And then you have another complex number, -2 plus 3i. So -2 is the real part, 3 is the imaginary part. And then what we're going to take a look at here are operations with these numbers. So to add complex numbers, you just add the real parts together, and then you add the imaginary parts together, and you create a new complex number. So 3 plus -2 is 1. 5i plus 3i is 8i, and that's the answer. Okay? Next example, subtracting. All right, same thing. Subtract the real parts, 6 minus 3, and then subtract the imaginary part. So make sure you're distributing the subtraction. So 4i minus 6i is going to be -2i, and that is the complex number solution to this subtraction problem. Okay, how about multiplying? All right, so 6i times -2i. So first, you think of the I as being like a variable. So if I'm taking 6 times -2, I'm going to get -12. If I'm taking I times I, I'm going to get I squared. But here's where a little trick comes in. So up here at the top, I squared is equal to, so if I is the square root of -1, if I square both sides, I squared would just be plain -1. So if I have -12i squared, it really means -12 times negative 1. And so now the two negatives are going to cancel, and I'm just going to get a solution of 12. So 6i times negative 2i is actually positive 12. All right, look at the next one. So the next one, I'm multiplying two complex numbers together. The last one I was multiplying two just imaginary. That's a pure imaginary number, that's a pure imaginary number. These are complex numbers. So to multiply them, I need to FOIL. So I'm going to take 5 times 2. I'm going to take 5 times 7i. That's going to be 35i. I'm going to take 3i times 2. That's 6i. And then lastly, I'm going to multiply the two imaginary parts together. So that's going to be 21i squared. But we just said that I squared is equal to negative 1. So think of this as being a negative 21. And so now that 10 and that negative 21 can simplify together to be negative 11. The 35i and the 6i can simplify together to be plus 41i, and this is our solution. So when you multiply two complex numbers together, you get a complex number as an answer. Okay? All right, how about E? What's 2 plus I cubed? So first off, you don't distribute. To multiply, okay, this literally means take 2 plus I times itself 3 times. So take 2 plus I times another 2 plus I times another 2 plus I. That's what we're going to do. Okay, so first, FOIL the first two together. That's going to be 4 plus. Now, we're going to get 2i, but then we're going to get another 2i. So that's going to be 4i. And then we're going to get I times I, which is I squared. And that's going to multiply 2 plus I. But first we're going to simplify this. Remember, I squared is negative 1. So this is 4 minus 1, so that's 3 plus 4i times 2 plus I. So we do need to multiply again, but we're just going to FOIL again. We don't have like a trinomial times a binomial. We just have two binomials multiplied together. So again, it's going to be 3 times 2, so 6 plus, all right, that's going to be 3i. That's going to be 8i when we multiply the inner. So 3i and 8i is going to be 11i. And then 4 times 1 is going to be plus 4i squared, which is actually minus 4. So 6 minus 4 is 2 plus 11i. And that is the solution of 2 plus I cubed. All right, one more operation, dividing. Well, to divide, you don't really divide. This is a radical, okay? I is the square root of negative 1. We don't like radicals in our denominator, so what we're really going to do is we're going to rationalize this. So remember what we do. If I have 3 plus I in the denominator, I'm going to multiply by 3 minus I. I'm going to multiply by its conjugate. That's how we deal with radicals, and so that's how we're going to deal with this imaginary part of this complex number. Now, I also have to multiply the top by 3 minus I, and then everything is going to get FOILed. Okay? So when I multiply the top, I'm going to get 21. I'm going to get minus 7. I, and then I'm going to get minus 3i. So I'm going to have minus 10i. And then minus I times minus I will be plus I squared. Now, on the bottom, I'm going to get 9. But then I'm going to get minus 3i, and then I'm going to get plus 3i. So the middle part's going to cancel. And then I'm going to have minus I squared. But the I squareds can be simplified because they're really negative 1. So 21 minus 1 is 20. Minus 10i is, well, minus 10i. And then again, I squared is negative 1. So this is really 9 minus negative 1, or 9 plus 1. So that's 10. But now, don't stop. Both the 20 and the 10 can be reduced with that 10, so we want to do that. 20 divided by 10 is 2. Minus 10i divided by 10 is minus I. And that is actually the solution to what you would get if you took 7 plus I and divided it by 3 plus I. Okay, but you divide by just rationalizing, and then it simplifies, and that's your answer. Okay? All right. All right. Last thing we're going to do is we're going to solve some basic equations. So like x squared equals negative 25. If all I have is an x squared, then I can just take the square root of both sides. Okay, so take the square root of both sides. You're going to get x equals the square root plus and minus of negative 25. But then the square root of negative 25 is going to be 5i. And that's my answer. That's it. Okay? So if all you have is an x squared, you don't have an x as well. If you have an x squared, solve for x squared. So get the x squared by itself. Divide by 2. Then you can simply take the square root of both sides. X equals the positive and negative square root of negative 9. But the square root of negative 9 is 3i. So that's our solution. Okay, go ahead and do the last one. And that's what you should get. Okay, move the 32 over, it becomes negative 32. Divide everything by 4, you get negative 8. And then you have to take the square root of negative 8. Well, the square root of 8 is 2 radical 2. But then there's also going to be that I because we were trying to take the square root of a negative. Okay, last one we're going to do is going to be a quadratic where we've got an x squared. We've also got an x, and we have a constant. So for this one, we're going to have to use the quadratic formula. Okay, so take all these numbers. So our a is 1, our b is negative 4, and our c is 8. And we're going to plug those into the quadratic formula. So what have we got? Negative b, so negative negative 4, so 4 plus or minus square root b squared. Well, if b is negative 4, that's going to be 16 minus 4 times a times c. Well, that's going to be 4 times 1 times 8, so that's going to be 32. And then 2a. Well, again, a is 1, so it's going to be a 2. All right, so now it's just a matter of simplifying. So 4 plus or minus the square root. 16 minus 32 is negative 16, so right away you see where we're going to get our imaginary part. 2. 4 plus or minus. All right, 16 is a perfect square, so that's 4, but the negative is going to give us 4i. Again, everything's being divided by 2, and everything can be divided by 2. So we want to go ahead and do this division. Simplify. 4 divided by 2 is 2, plus or minus 4i divided by 2 is 2i, and there are the two complex solutions to this equation. 2 plus 2i and 2 minus 2i. All right, that's it. Take a look at your worksheet, and let me know if you have any questions.